All right, thank you. So, hello everyone. My name is Josh. I work at Anaconda, and this was me at 12 years old. And if you believe the internet, I am still 12, but we'll gloss over that one. And I created a program called EduBlocks. For over a decade, I've been helping people learn Python, like this Dutch beginner here. So that is what I'm passionate about and sort of the topic that I'll be talking about today. So just to set a bit of background, let's take a step back and look at how beginners, specifically kids, which is what I'm focused on, learn how to code. So you might be familiar with this program on the screen. This is Scratch, and it's a free and browser-based platform that allows kids to drag and drop blocks on the screen to create games, stories, apps, that kind of thing. And it's a programming tool for learning basic programming concepts, where you drag and drop blocks on the screen and figure out how things work. Now, as kids progress on their learning journey, they will eventually switch to text-based programming, usually Python, because as we all know, it's a good language to learn. It's easy to use. And they get presented with something that looks like this, which I'm sure we're all familiar with. However, there is a problem. It's very unclear where to start, because we've gone from Scratch, which is this fun thing where the cat moves across the screen, and it's all fun and playful. Yet we throw beginners into a blank code editor where they have to type things out. And they come across unfamiliar things like errors and needing to learn how debugging works and what are these import statement things and all of that that Scratch doesn't necessarily teach kids. Most haven't typed a line of code before. One thing that sticks out in my memory is I used to run a code club where I live, and one kid came along, I think he was about 8 years old, and he asked what a keyboard and mouse was, because we live in this world of touchscreen iPads and phones and all this kind of thing. So trying to get this particular learner how using Python was a little bit of a challenge. So there's all these things that culminate into quite a demoralizing experience. So I figured throughout my learning journey as a student myself that there was a need for a tool that sat in the middle between Scratch and Python. So the solution that I came up with was block-based Python programming, which is EduBlocks. So it's keeping the block format that the kids are familiar with. However, it's introducing text-based concepts to make it easy to learn the Python syntax. So how it works is you drag and drop blocks onto the screen, and the text code is generated on the left. The kids can also type in the code editor, so they can start to play around with actually typing code out as they're dragging and dropping the blocks. And the blocks are a one-to-one representation of the Python code. Now, the important thing to note here is that it's a browser-based application, which means it's accessible to everyone, and it's also free. I'll talk a little bit about why that's important. Now, because we're running in a browser, we have a challenge. Where do we run the Python code? Python is not a first-class citizen in the browser world. JavaScript is. So what are the ways in which we can execute Python code? So EduBlocks is mainly for schools and educational settings. So I want to talk a bit about why browser-based Python is important in an educational context. Unfortunately, there are unhelpfully restricted and bureaucratic computing systems in schools, out-of-date and underpowered machines, lots of Chromebooks and Windows 10, even Windows 7 machines. We also can't assume that Python is installed locally, so that's a challenge. And perhaps the biggest one is that in a lot of schools, IT teams are outsourced, so they're not actually in-house. So if you want to install something, one example that I came across was a school that had a lead time of 12 weeks to install something basic like Python, because it had to go through approval processes, and the team was external, so they had to deal with other schools as well. There's all this bureaucracy in the way of installing Python, but a browser is everywhere, which is why it's the ideal candidate. And also, it means that there's no installation required, and it works everywhere, whether that be on laptops, mobile phones, and yes, even in your car. Scalability is also another cool thing about running in the browser. We can serve thousands of students simultaneously. There's no server capacity limits. And to use a buzzword, we're running Python on the edge. Okay, so some of the potential solutions I explored to run Python in the browser. What I started off with was this. So this was EduBlocks all the way back in 2016 when I first released it. There were these little boards called the Raspberry Pi, which were really popular in schools, more popular now in industry. So the way I did it was I had a locally installable server that you installed on the Raspberry Pi, and then the browser would connect to that via a WebSocket, and then the browser could say, hey, I've got this code that I want to execute, stream back the output, and handle inputs if I was using input statements and things like that. That was the first attempt at this. As EduBlocks got more popular, I switched to a third-party service which behind the scenes used something called Sculpt. And what Sculpt is a JavaScript module that is a browser-based Python 2 implementation. It has some support for Python 3, but it only goes up to Python 3.7. And what Sculpt does is it takes Python code and translates it into JavaScript code. So that comes with all of the limitations that you can probably expect. Only a subset of the Python standard library is available, and obviously only things up to Python 3.7. And there are no /few external module support, only things that the Sculpt team and external contributors have developed in Sculpt's kind of framework. And as we were growing, teachers were asking for us to implement things like f-strings, which are only available in more modern Python versions. So we quickly realized that there was a need to change to something else. So the obvious thing would be to run Python in the cloud, right? And this is a very acceptable way to do it. But EduBlocks being a free product, and it's important that it's free because that means that it's accessible to anyone, and there's no barrier to entry. But this solution would be quite expensive because we have millions of users, and it's kind of hard to scale when thousands of students are hitting it all at once. You can imagine that this is used in school settings, right? So if EduBlocks is being used only in one school, that's at least 30 students. There's also the challenge of visual libraries not being supported if we ran Python in the cloud, or at least not easily. There are ways to do it via like VNC connections and all of that stuff. But libraries like Turtle are quite important to our users because it's an easy way for students to see something visual on the screen. Python's a very textual language, so being able to do turtle.forward is to students quite fun, so that was really important. And also running Python in the cloud meant that we lose the capabilities to talk to the browser world, and there's lots of capabilities that the browser have that would be interesting to implement into our tool. So those were that's the journey and some of the considerations of ways to run Python in the browser that we have either tried or considered. And that led us onto the final solution, that is PyScript. Now, the important thing to say is I do work for Anaconda, but this is something that I started exploring way before I even got a job offer. So just keep that in mind. I'm not trying to, even though PyScript is an independent project, I'm not trying to sell you anything here, I promise. But what PyScript is it's an open source platform for Python in the browser. And my colleague Nicholas puts it like this, which I think is a very good way to describe it. If the Python in the web had a baby, it would be PyScript. And that's basically what it is. So how does PyScript work? So if you think of the white box as the web browser, At the bottom, there are Python interpreters, and these run on top of WebAssembly. And what WebAssembly is, in a very simple way, is a virtual machine in the browser. If you saw the talk before, that was a lot more in-depth in the technical details of that. And it's a sandboxed environment inside the browser. PyScript has two interpreters that can be used. PyDide, which is for CPython, and also MicroPython, which is the variant of Python that runs on microcontrollers. But it just so happens, because of browser constraints and needing to download files and the costs that come with that, that MicroPython is actually very well suited to a browser environment because it's a small download and fast to run. On top of that, we have PyScript, and what this does is it enables easy access to these interpreters and makes bootstrapping those within the browser really easy to use. There's also then a FFI between JavaScript and the Python world, so the two worlds can interact with each other. So you can use things like the sensors on mobile phones and computers, PCs, and also all the web APIs that you can use in JavaScript. You can access those in a Pythonic way using the libraries that are included with PyScript. And then on top of that, there are also frameworks in the PyScript world. So these help you build UIs and apps easily with PyScript. So two of the popular ones are LTK, which is a jQuery-based UI framework, and also Invent, which me and Nicholas and another colleague, Martin, are working on to make building UIs with PyScript easy for beginners. And then on top of that, obviously, you have your user code. So how does PyScript work? You simply import the CSS that handles some things like making the terminal that is included a bit nicer on the page, and error messages and things like that. And then you just import the PyScript core.js file. And it's as simple as that. You now have Python in the browser. So once you've imported those, you can add a script tag, just like you would if you were running JavaScript, but you add type equals py onto the script tag. And you can also add lots of different attributes that I won't go into detail about, and I'll put a link to the docs at the end. But I'll just add a terminal here because I'm doing print hello world. And then inside of that, you can add your code. You can also link to a .py file if you want to keep things a bit nicer, but for demo purposes, I've kept it like that. The third element to PyScript is the config. So this is where you configure your PyScript environment. So you can add things like your packages from PyPI. Most packages that are pure Python work. There are some packages that have C code that have been modified to work with PyDide as well. You can also add things like files. So if you want to include text files, images, sound effects, anything you can think of that works in a browser, you can add here, and they will be accessible from your PyScript app. And you can also import things like JavaScript modules. So if you have something from the JavaScript world that you want to use in Python, if you add it here, you can do import JavaScript module and use it in a Pythonic way. It automatically allows you to use the same commands in Python. Pull these things together, and you have a working Python browser-based application. This is what the code that I just showed you would generate. You can deploy that to static hosting, so if you upload all those files to something like GitHub Pages or PyScript.com, which is a free app that Anaconda provide, you just give someone a URL, they load it up on their phone or PC or wherever that has a web browser, and they can access your Python app, no installation needed. And that's the cool thing about PyScript. It's making the deliverability of Python really easy as well. So back onto EduBlocks for a second. Most of our users are beginners, and common programs are very much like this on the screen, which include blocking things like loops and input statements and things like that. And if you were to run that, as I showed you in the examples before, you would get something that looks a little bit like this. The code that I showed you would run on the main thread of the browser, and anything like loops or blocking calls will simply crash, which is not ideal because that's not the experience we want to give our users. And that's because the JavaScript world is asynchronous and Python is synchronous, so the two worlds kind of collide. Now, PyScript have addressed this problem by implementing something that I'm going to introduce, and this allows us to give our users something that's very close to a local Python experience, especially with EduBlocks, with things being like this, that include while true statements and all that kind of stuff. Blocking calls are a must, so that was a requirement as well. So what are these magical things? They are web workers, and essentially they are just separate processes in the browser, and they're really good for offloading heavy computation and blocking calls so that you don't crash or block the main thread. And it's really easy to use. You simply just add a worker attribute to the script tag and add some headers to the web server that's hosting your PyScript application, and away you go. You have PyScript running in a web worker. And then the workers and the main thread can talk to each other, so you can have the main thread handling all the things like UI and like the user-facing stuff, and then you offload your heavy computation to a worker. So this was our initial implementation. You would press run. It would take the blocks, it would convert the blocks to the Python code, it would upload all of the files that are related to PyScript to static storage. We're using Google Cloud. And that would then just show the app to the users, like on the right-hand side of the screen. However, we're dealing with beginners, and beginners often make mistakes. So you would change something, and then you would press run, and it would have to go through this whole process again. And you can imagine a class of 30 students on a relatively slow internet connection. It could take up to 30 seconds at a time. And this was less than ideal. So this led us on to working with the PyScript team to come up with another solution. Now, if you can't tell by my accent, I come from the UK, and I live near a place called Blackpool. Has anyone heard of Blackpool? Yeah, okay, a lot of people. And on the Blackpool beach, there are donkeys. And bear with me, this will make sense in a minute. And what these donkeys do is they sit around and wait for a job. So the answer, believe it or not, was a donkey. There is actually an API in PyScript called the donkey. And what this does is it's a PyScript worker that bootstraps when the page is loaded, and it waits around waiting for code to execute. So how does it work? You import the donkey, you call it, you give it some config, like what interpreter do I want to use? Do I want it to be persistent between runs? This is basically just like clearing the globals and things like that. Do I want a terminal or not? EduBlocks, most people are using the terminal, so I use that. And then config is where you put your JSON config, like what I showed you before for configuring packages, files, JavaScript modules, things like that. And then you take your Python code and say execute, and then it runs in the browser. It's as simple as that. So you're starting to see how you can integrate PyScript into an application rather than just developing a PyScript app, which is what I'm doing. So I'm actually integrating PyScript here. And the donkey is a great way to do that. You can also evaluate code. So I can pass things like 5 + 5, and it will just return the result of that. So that's a really cool feature as well. And unfortunately for the donkey, I can also kill it. I'm sorry about that, but so this is my implementation. So I drag and drop the blocks. The PyScript donkey loads in the background on page run. If I use something like turtle and press run, it will run instantly as well. And if I stop it midway through a program, it will kill the donkey and restart it up, ready for the user to run code again. So it's really that simple. Another honorable mention in the PyScript world of how to run PyScript within your app is the PyScript Bridge. This is a relatively new feature in the latest PyScript release, or it might be one from a few releases ago because PyScript releases all the time, which is a cool thing because it's always being updated. And it's an easy way to interface between the Python world from the JavaScript world. So I can call my Python functions from JavaScript. So say I have a simple Python file like this where I've got a function that does a thing, and I want to be able to call that from JavaScript. So in this case, it's called mymodule.py. If I create something called mymodule.js and import the PyScript bridge, I can say what type of interpreter I want and whether I want it to be a worker or not. And then I import that inside of a JavaScript file, and then specifically reference my function that I want to use, and I can simply call it like that. It's really that simple. So the two ways to run PyScript from your JavaScript application or any web application is the PyScript Bridge and the PyScript Donkey. And those are the two things that I've used to use PyScript as infrastructure rather than PyScript as an app building framework. So a quick recap. Running Python in the browser removes friction for developers and end users. JavaScript-based Python is not real Python, even though some people think it is. PyScript is real Python. PyScript works in the browser, which is everywhere, so it's making it easy for your users to access. And PyScript is very powerful, yet easy to use. So here are some resources. PyScript.net is where you want to go to find out about the open source project. There's a vibrant Discord community that you can join via the PyScript.net website. The core maintainers are on there. They're really helpful at asking any questions. Special shout out to Andrea, who we nickname as Web Yoda. He is the mastermind behind all of the web-based stuff and wizardry that goes on there. If he doesn't know about it and it's web-related, it's probably not worth knowing. So you can go ahead and poke Andrea on the Discord server, and he's always great to chat to about web and Python-related things. There's a PyScript documentation, which is the place to go if you want to find out how to use all this cool stuff that I've showed you, and also all of the other things that PyScript has to offer. And EduBlocks, which is my project that I work on at Anaconda, is edublocks.org. So thank you very much for listening, and any questions?
Hello, Josh. So I have a question. How many users do you have a month?
So on EduBlocks, we hit around 300,000 students, but they run over like 1.5 million PyScript projects. So we're handling a lot of projects, and it costs us absolutely nothing, which is why running Python on the edge is great, right? Because we have all the capabilities and none of the cost.
Yeah, I was going to ask, how much does it cost? Nothing.
Zero.
Yeah. Okay.
Okay, thanks for the question. Let's have another question from that side.
Did you have any challenges with the load times and the size of the like the entire website, especially on the first load, when it needs to download all the like PyScript, Pyodide, Python, and all the other packages, or is it just not relevant for your use case?
Yeah, so there is obviously a cost to downloading Pyodide because it installs the standard library and also the packages as well. So that can be a little slow on the first load, but it does cache Pyodide and the packages after that first time, so it gets a little bit quicker. But one of the things that I do want to look into is, because we're using PyScript, we can also access MicroPython. So for a lot of the basic use cases of print hello world and things that don't really use external modules, MicroPython is smaller than loading an image on a web page. So that's something that I want to look into, some sort of like dynamic checker that will look at the code and determine whether it can be run on MicroPython or Pyodide. So that's something I want to look into to reduce that. But yes, there is a cost on the first load.
Thank you very much for the question. If anybody else in the room has a question, please get up and get to one of the microphones. While we wait for that, there's just a comment from the online audience. Benjamin says that he doesn't have a question in particular, but wants to thank you for making this possible. So as I see, we have no other questions from the room. So let's have another big thank you applause for Josh. Thanks for coming again.
Thank you.